Okay, this lesson is on area of regular polygons. So the first thing that we need to know is what a regular polygon is. So a regular polygon is just a shape that has all equal sides and all equal angles. So if you think about like an equilateral triangle, that's not exactly equilateral, but it would mean that all three of these sides are the same and all three of these angles are the same. This would be a regular polygon. A square is always an equal or a regular polygon because all four of the sides are the same and all four of the angles are all 90 degrees. So I'm just going to write down the definition of a regular polygon. It's that all sides and angles are equal. So the shapes that we'll be looking at for this section are going to be triangles, hexagons, pentagons, octagons, things like that. So that's a regular polygon. And one thing before we get into finding the area is we have interior angles and we have exterior angles. So I'm going to attempt to draw an octagon. We'll see if it'll recognize it. It's not the best, but it'll do. Okay, so this is my slightly misshapen octagon. It's supposed to be equal. Let's just assume that all of these sides are the same and all of the angles are the same. So if we were to extend these lines here, then each of these right here, I'll do this in red, each of these angles, these are called our exterior angles because, shocker, they're outside of the octagon. So the way that we find the value of the exterior angle is that you just take 360 and divide it by the number of exterior angles that there are. So in an octagon, that would be 8, which means that each of these angles would be 45 degrees. Because if you went all the way around the circle, that would be 360 degrees. We have 8 angles, so that would be 45 degrees each. Then we have our interior angle. So let's do purple for this. The interior angle is just the rest of this. So each of these has an interior angle just like this. So the purple ones are the interior. And what do you think the relationship is between these angles? If we look at an exterior angle and an interior angle, can you tell what relationship they have? If we look, the interior and the exterior form a line. So that means that the interior plus the exterior has to equal 180 degrees. So if we do some math here and subtract the exterior angle from both sides, we get that the interior angle is equal to 180 degrees minus the exterior angle. So for an octagon, the interior angle is equal to 180 minus 45 degrees, which means that the interior angle for an octagon is 135 degrees. And that'll be useful when we're finding the area of these regular polygons. So that's interior and exterior angles. And now we're going to jump into finding the area. So we are going to start off with a hexagon, and I'm going to try to make this a good hexagon. Well, that turned out pretty okay. Okay, so we have our hexagon here. So the first thing that you want to do is make small triangles. And what I mean by that is we're going to take line segments from one vertex to the opposite one, and we're going to break this up into 6 smaller triangles, just like this. Because we don't know what the formula is to find the area of a hexagon, but we do know the area of a triangle. So if we have the information that we need for the triangle, then we should be able to find that area, multiply it by 6, and that gives us the area of the hexagon. So we need to find the area of the small triangle. So the area, remember, is 1/2 the base times the height. So right now, we don't have any information about this hexagon because it's just our example. It's just like an example. So when we do ones with numbers, then we'll be able to use numbers in our example. But right now, this would be our height. So this is our height. And then this right here is our base. So if we find that, that would be the area of this triangle. And we know that there are 6 of them because it's a hexagon. So if we multiply that area by 6, that would give us the area of the hexagon. There's a special name for this height when it's drawn like this. This is called an apothem. So the apothem is drawn from the center of the regular polygon and it's perpendicular to the side. So it doesn't have to be just on this one. There's an apothem here, and there's an apothem here. And so you can choose any triangle and draw the apothem there. And that is what we're going to use for our height. So this will always be the apothem. And I know that's kind of a funny word. It sounds like a possum, but like with a lisp, but it's an apothem. So altogether, once we find the area of that small triangle, to find the area of the hexagon, that would be the total area equals 1/2 the base times the apothem times 6. And this part, the 1/2 the base times the height, or times the apothem, that's our orange triangle. Then we multiply it by 6 because there are 6 of them. So that is the basic idea of finding the area of a regular polygon. Now we're going to go through 3 examples and figure out how to do this. Sometimes finding the base or the height, you're going to need to use your trig ratios, like sine, cosine, and tangent. Most of the ones that we're going to do, you can use special right triangles. So if you remember those, that would be helpful for this homework and for this quiz. So our first example is going to be another hexagon. So I'm going to try and draw one that has even sides. Okay, so that's the hexagon. And the information that is given is that one of the sides is 10. So that means that all of these sides are 10. So the first thing we want to do is we want to draw lines to break this hexagon up into triangles. Because we know how to find the area of a triangle, we don't know how to find the area of a hexagon. So we want to find the area of one of these small triangles. And I'm just going to choose the bottom one every time because it's easier to see and like make sense of. So that wasn't a very straight line. Okay. So this is our apothem. We know that the base is 10, but that's it. We need to know the height, but we don't know the degrees in this triangle or anything like that yet. So if you think about it, if we have all the way around in the circle, that would be 360 degrees. And how many small triangles do we have? we have 6. So that would be 60 degrees for each of these. I'm going to make this a little smaller. So this angle right here, is that 60? It wouldn't be 60 because that's for this whole angle right here. But we know that that apothem, it's cutting that angle in half. So that means that this degree right here is 30. Okay, I'll just leave that one there. So we have that degree measure. Yes, okay, I did it. This degree measure right here is 30, which makes this one, what? This would be 60 degrees. So now we have a 30, 60, 90 triangle. And instead of having this whole base be 10, I'm going to have us look at just this little triangle. So I'm going to use blue because that's my favorite color. So we'll say that we're finding the area of this little triangle. Okay. So since the whole side is 10, half of that would be 5. And in our little triangle, this is the short side. So we know that the hypotenuse is 2 times that, so this would be 10. And then the medium side is 5 times the square root of 3. And that's just using those special right triangle rules. So if you need to go back and review that, that will be very helpful. So now we know the apothem because we found all of the sides in this triangle. So I'm going to say the area of this small blue triangle is 1/2 the base, which is 5 here because we're just looking at the blue part, times 5 square root of 3. So the total area here is 25 square root of 3 divided by 2. So now if we want to find the area of the hexagon, it's my very quick hexagon, we have to take the area of the small triangle, the blue one, and what do we multiply it by? Is it 6? So here we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because each of these, we could draw the apothem down, and then we would have 12 of these little blue triangles. So we're going to take that and multiply it by 12. So we get 25 square root of 3 divided by 2 times 12. And I'm going to use my scientific calculator here. So we have 25 square root of 3 divided by 2 times 12. And that tells us that the area is 259.81. I don't remember if on the test if it rounds it to 1 decimal place or 2. We'll just round it to 2. So we have 259.81. And that is the area of that hexagon. Okay, our next example is going to be a triangle. Oh, I didn't hold it long enough. Okay. Okay, so I'm going to give that this side is 10. So once again, we want to split this up into smaller triangles because we don't know what the height is on this triangle. But if we break this up into smaller triangles, then we should be able to figure it out. Okay, so now we have our triangle broken up into 3 smaller triangles. We need to find the apothem here. And once again, we know that the apothem is breaking this, the orange triangle, which is like 1/3 of the bigger triangle. We know that that's breaking up that side into half. So I'm going to say that this is 5. So now instead of finding the area of the bigger triangle, we're going to find the area of the smallest triangle here. So we're going to find the area of the blue one. And my triangle obviously isn't perfect. It's a little off, but that's okay. So if we have all the way around, this is 360 degrees. And if we want to find just this angle, we're going to take that and we're going to divide it by 1, 2, 3, 4, 5, 6. So we're going to divide it by 6. That would be 60 degrees. So that means that this angle right here is 60, which means that this is 30. So now, instead of having the short side be 5, now we have that it's the medium side that's 5. And these ones were a little bit more complicated. But we should still be able to figure it out. So this is 5 times, or 5 is whatever the short side is times the square root of 3. So we're going to divide that by the square root of 3. So we get smiley face equals 5 square root of 3 over 3 if we rationalize that denominator. So now that's the short side. So right here we have 5 square root of 3 over 3. So to find the area of the blue triangle, we take 1/2 the base, which is 5, times the height, which is 5 square root of 3 over 3. So I'm going to take that and I'm going to type it all into my calculator. So we have 1/2 times 5 times 5 square root of 3 divided by 3. And that gives us 7.22. And I'll be looking for decimal places anyway, so we can round it at this point and it won't be a big deal. So now we're going to look for the area of the big triangle. And how many of these blue triangles do we have in here? We'd have 1, 2, 3, 4, 5, 6 of them. So we need to take that 7.22 and multiply it by 6. So I'm just going to take this and multiply it. 7.22 times 6. So we get 43.32. And if you round it like this, if you round it and then multiply it like we did here, your answer might be a little bit off of what the multiple choice is on the quiz and on the test, but just pick the closest one to this. Because on the answers on the quiz and on the test, it wouldn't round this part, so then it might be a little bit higher on that decimal place, but it should be pretty close, like within 1 unit or so. So that's our example there. And then we have our last example. So on this one, we're going to do an octagon. So let's see if I can draw an octagon where it actually looks like an octagon. Oh, okay. Ooh, that is a very ugly octagon. Okay. I'm going to just grab a picture. Octagon. If I could spell it right, that'd be great. Okay, let's see if I can copy this. And then can I paste it in here? Oh, good. Okay, cool. So that's our octagon. I'm going to make it a little smaller. Okay, so now the information that I'm going to give us here is that the side is 12. So the first thing that I'm going to do is I'm going to break this up into smaller triangles. And then I'm going to draw the apothem like this. So we know that that piece is 6, and that's what we know so far. If we take 360 degrees, which is all the way around like this, we would have to divide it by 16 to get that, to get this angle right here. So let's do that. We'll do 360 divided by 16. So that's 225, or not 225, 22.5 degrees. So this is 22.5. And we want to find this height of the apothem. So on this one, we're going to have to use a trig ratio. This is our angle. Right here, this is our angle. So this side is the opposite, and this would be the adjacent, because that one's the hypotenuse. So which trig ratio uses the opposite and the adjacent? If you remember SOHCAHTOA, it would be tangent, because tangent is opposite over adjacent. So we have tangent of 22.5 equals 6 over that height. So I'm going to multiply by h on both sides. So we get h tangent of 22.5 equals 6. And then to get h by itself, we have to divide by tangent of 22.5. So we get h equals 6 over tangent of 22.5. So we have 6 divided by tangent of 22.5. And as you can see right here, it's in degrees. Oh, goodness. Okay. Tangent of 22.5. So that tells us that the height is 14.49. So we'll put that in here. So now I'm going to color in this triangle right here. This is going to be our blue triangle. So to find the area of the blue triangle, we do 1/2 the base times the height. I'm going to draw a line here. So the area of the small triangle is 1/2 times the base times the height. So that gives us 43.47. And then we have to multiply that blue triangle area by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, because it's an octagon. So that means that we have 16 of those small triangles. So we take, if we want to find the area of the octagon, then we would do 43.47 times 16. And that tells us that the area is 695.52. And that would be the answer on the quiz or the test. Okay, and those are our 3 examples. I have a homework assignment on Canvas already, and I have the key posted on the website if you want to check your work, and then go ahead and take the quiz.